Day 21, Book Recommendation System using Collaborative Filtering. Let's create a book recommendation system today using the collaborative filtering, where collaborative filtering is a popular technique used in recommendation systems where recommendations are based on user item interactions. Here we'll use the item based collaborative filtering approach to recommend books based on user preferences. We'll use the cosine similarity measure to find similar books based on users' rating. For this example, we'll use a sample data set of books ratings by users, and I'm going to make that up. So let's get started. So I'm going to open my project. I have my project which is date21.py. I have not written anything yet here. So we're going to start with the coding part. So first step, as usual, import the libraries. So I'm going to import the necessary libraries, which is pandas and cosine similarity. Now pandas is used for data manipulation analysis. We use it to load and transform the books and rating datasets into a user book matrix. Cosine similarity is a function from sklearn metrics pairwise that calculates the cosine similarity between vectors, which we use to compute similarity between books based on user ratings. Now let's go ahead and create a sample data set. So what I'm going to do is I'm going to just make my own. If you have a real data set, just use that. So I have a data here, data object dictionary, which will have user IDs, which is 111. So there's like 4 users here: user 1, user 2, user 3, and user 4. Next, the book title are the book A, book B, book C, and book D. So these are the 4 books that I have, and they have kind of corresponding to the user IDs that I've recommended those. And their rating, here is the ratings for each book that they have read and what it is. So once this is done, once our data set is available, next thing that we'll do is we'll convert it to data frame. Now to do that, I am going to use pd.dataframe and take that data in here. Next, I'm going to print the data set by saying print df. Next step, we'll create a user book matrix. Now this user book matrix will be made up of pivot table. Now the pivot table is used to transform the data set into a user book matrix where each row is a user, each column is a book, and the values are the ratings. So that's what we have created here: index user ID, columns book title, values rating, fill in a, and then we are printing that user book matrix. Next step is to calculate the cosine similarity of this. We calculate the cosine similarity between books based on the user ratings in the user book matrix. To do that, I'll say user similarity is equal to cosine similarity. User book matrix is what I'm going to pass to it. Similarly, user similarity df, where we are going to create a data frame using the user similarity. The index is equal to user book matrix dot index, and columns equal to user book matrix dot index. Next, I'm going to print this user similarity matrix, and then let's write a function to recommend books based on user similarity. In this particular function, which is recommend books, I have taking the user ID, similarity matrix, user book matrix, and top n equal to 3. And then I'm going to check if user ID is not in similarity matrix dot index. I'm going to say user not found in the dataset, and I'm going to return an empty array. Now next, I'm going to try to, if there is some data, then I'll say get similarity scores for the user. I say similar user equal to similarity matrix, pass the user ID, sort the values ascending equal to false. So I'm doing in a descending order, and then drop user ID in this particular case. Next, I'm going to aggregate the ratings for similar users weighted by similarity. To do that, I'm going to first create an empty dictionary of recommended books equal to empty. And then for similar user, similarity in similar users.items, I'm going to create a variable called as rated books and check if and kind of assign user book matrix dot location based on the similar user. Then I'm going to write another for loop inside there where I'm going to go over each and every rated books where rated books is greater than 0. I'm going to get the book and rating and go through that and check if book is not in user book matrix or user book matrix is dot location in user ID comma book equal to 0. So if that is not there, then I say recommended book equal to recommended books, get the book, at 0, rating and time similarity. Now, once I have that, goes through that, I will probably have a bunch of recommended books in here. Now, I'm going to sort those books by aggregated score and return the top recommendation. Let's say recommended books equal to sort the recommended books by key lambda, x equal to x of I, reverse equal to true. And I'm going to return the book for book score in recommended books back to the person who actually, the function that called it. So now to get that recommendation for a particular user, I'm going to say user ID. Let's say for one, I want to get recommendations. So I'm going to recommended books for user ID, user similarity df, pass that user book matrix, which I'm going to get from above here, which we have calculated. And then I'm going to say top n equal to 3. So this will give me the books recommended for this particular user here. So let's run this up. Let me make sure it's saved. Okay. And then I'm going to open this. Let's make sure we're in the right folder. Day 21. Perfect. Python day 21. Now the recommended books for this user who have read book A, B, and C. And it kind of gives me here, look at the user similarity. The books recommended for user 1 is book D and book E, because the user has not read those books. Of course, A, B, C are the ones that they read. Let's pick a user, for example, user 4, who has read books A and C. For him, for the user number 4, we have book B, D, and E. These are the 3 recommended books that are available for this particular user. So that kind of concludes our book recommendation system using collaborative filtering. If you are able to figure this out and write the code and follow along, that's good. If not, if you have any questions, let me know and I'll get back to you.